Hi everyone! Welcome to our Scientastic class. I'm teacher Bregeline and I am here to help you understand how science works in everyday life. Are you ready to join me for today's lesson? Come on, let's learn together. Today, we are going to talk about the one who is responsible for the beauty of sight. It helps us to see things. This is the sole source of food generation for all living organisms here on Earth. And the one that we must focus to see during our darkest moment. What is it? Yes, it's light. The science of light has gone all the way from the mere transfer of energy to the creation of colors for entertainment and other purposes. Most of our gadgets are light emitting for efficiency when used at night. In the field of medicine, light is used to cut the skin for surgery like laparoscopy. The health sciences are also using light for other medical purposes. But the most important is for humans and animals to see the beautiful world through light. What is light? Light is a form of energy that can be converted from one form to another. Light travels in a straight line. Light travels much faster than sound. For example, thunder and lightning start at the same time, but we will see the lightning first, then hear the sound of thunder. When a starting pistol is fired, we see the smoke first and then hear the bang. Light travels very fast, about 186,000 miles per second. And light can create also shadows, like this. Study the figure to recognize the basic parts of a wave. Light waves travel at a given velocity and wavelength. Wavelength is very important because it relates to the energy of light. Wavelength is designated by the Greek letter lambda. Let's analyze the figure. The wavelength of light. The longer wavelength means it has lower energy. And the shorter wavelength means it has a higher energy. Light energy is a form of electromagnetic radiation that can be seen by our human eye. Electromagnetic radiations with shorter wavelengths than visible light are called ultraviolet rays, X-rays, and gamma rays, while electromagnetic radiations with longer wavelengths than visible light are called infrared, microwaves, and radio waves. The electromagnetic waves exist in a vast range of wavelengths. Our eyes are sensitive to only a very narrow band. This narrow band wavelengths is what humans can see. We refer to it as the visible light spectrum. The colors of the visible light has different wavelengths and frequencies. The wavelength of each color decreases from red to violet, while its frequencies increases. The frequency of the colors of light is directly proportional to the energy it carries. Thus, red color with the least frequency has the least energy, while violet with the highest frequency has the highest energy. White light is not a single color. It is made up of a mixture of the 7 colors of the rainbow. The separation of visible light into its different colors is known as dispersion. Let's explain dispersion further. When the white light is made to pass through a prism, formation of a spectrum of 7 colors occurs, showing that white light is a combination of 7 separate colors. Prism only acts as a medium for the dispersion of light made of the 7 colors. The wavelength and frequency of those deviated colors is different. They deviate differently at angles. Color red deviates the least since it has a maximum wavelength, and color violet deviates the most since it has the least wavelength. When sunlight passes through the atmosphere, it hits nitrogen and oxygen particles. These particles scattered light of a smaller wavelength. Violet light is basically scattered even a touch more strongly than blue. More of the daylight entering the atmosphere is blue than violet, but our eyes are somewhat more sensitive to blue light rather than to violet light. Therefore, the sky appears blue. As the sun gets lower within the sky, its light is passing through more of the atmosphere to reach you. As a result, most of the blue and violet get scattered before they reach our eyes. Because of this, the less scattered light, like red or orange, reaches our eyes, making the sunset color red. Wonderful scenery can be seen only when the sunlight and rain appear at the same time. When light enters a water droplet, it bends slightly in separate angles form different light rays. Those bent light rays are seen distinctively by the human eye, and that is how one can see a rainbow. The color of an object appears depends on the color of light it reflects. Example, what is the color of an apple? Very good, it's red. A red apple only reflects red light. This is all for today, class. See you on our next episode. Bye!